So questions related to the waves. You can use chat, mic, or screen annotation. A ray of a light in a glass is incident on a boundary with air. State what happened to the ray when the angle of incidence is less than critical angle. So if the angle is less than critical angle, then what will happen to the light? It only refracts. But if the angle is greater than the critical angle, the angle of incidence in a denser medium is greater than critical angle, then what will happen? There will be a total internal reflection. If you write only reflection, then your answer will not be considered as correct. You have to mention the term total internal reflection. Figure 6.1 shows a ray of a light which is incident in a glass block. The critical angle of a glass block is 41. On a figure, draw without calculation and continue the ray until it leaves the glass. So first what we do, we draw a normal. Normal is always perpendicular to the surface. So if this angle is 30, angle with the surface is 30, how much this remaining angle? Because the total sum should be 90. So what is this total angle? So this angle is 60. So it means the angle of the incidence is 60 and the critical angle is 41. Because the angle of the incidence is more than the critical angle, what will happen? Light will undergo a total internal reflection. So it will reflect back in the same medium. Then we draw this again the normal. Whenever it strike the surface, always draw the normal. When we draw this normal, how much is this angle? What will be this will be 60. What will be this angle? Yes. What will be the angle here? The new angle of incidence. That will be 30. Good. Because the total sum of the angle of a triangle should be 180. So this will be 90, 60. So this is definitely 30. If this angle is 30, it means now this angle at this position, critical angle means whenever, for example, say this is a surface, what is the meaning of a critical angle? Critical angle means it's the angle of the incidence for which the angle of refraction is 90. Say, when they say that this is 41 is a critical angle, what does it mean? It means if this angle of incidence in a denser medium is 41, light will travel 90 degree to the surface, 90 degrees to the normal, or parallel to the surface or along the surface. So the angle of the incidence is called a critical angle if the angle of refraction is 90. The value of the critical angle is given in the question, it's given 41. They mention here the critical angle for this glass is 41. And usually the glass which we are using in our lab are having a this range like 40 to 42. So because the critical angle is 41, here angle of incidence 60, total internal reflection. But this case, the angle of incidence is 30 and the critical angle for a glass that is 41 here. So this angle is less than, so simple refraction. But where it will refract, moving from glass to air, it will bend away from the normal. So any angle you can draw because we don't have to do any calculation. We just have to complete the path. So it will bend away from the normal at any angle of refraction. Then calculate the refractive index. So if you want to calculate the refractive index and we have the critical angle is given 41. So if we need the refractive index, the relation between refractive index and critical angle, n equal 1 over sine c. So refractive index 1 over sine and the critical angle is 41. So 1 over sine 41, you get 1.52. What will be the unit of refractive index? What is the unit of refractive index? The refractive index does not have any unit. Why? Because refractive index is a ratio, comparison. Comparison cannot be cannot have a unit. That's why refractive, there is no unit for refractive index. It's just a number. Like when we get a refractive index 1.5, it means compared to air, it has 1.5 times tendency to bend light. A loudspeaker produces a sound wave with a constant frequency. What is the meaning of frequency? Definition of frequency. How you define frequency? Number of vibrations or number of waves in 1 second. Per second. Yeah, that's right. Number of waves per second or number of vibration per second is refers to frequency. The sound waves travel in the air and approaches a gap which is smaller. You have to complete the pattern because we have a narrow gap. What kind the maximum diffraction? So how we represent it will be curved. But keep one thing in mind that when you draw, like example, if this was say 2 centimeter, so the wavefronts which you draw, they should also have a gap of 2 centimeter. And narrow gaps, maximum diffraction. The next is what is meant by compression, how we define a compression. It's in a longitudinal wave. So high pressure and the molecules are closer. The width of a gap is smaller than the wavelength. On a figure, draw the pattern. So that we did already. The barrier is adjusted so that the gap become wider. How the affect the pattern of a compression? So if we use a wider gap, so what will happen? It will be less diffraction or reduce the diffraction or less spreading. Less angular width, that's also good. You can mention this word. The frequency of a sound is 6,800 hertz. The speed of the sound is 340. We need the wavelength. How to work out the wavelength? You have the frequency, you have the speed. What is the formula which relate the frequency, speed, and the wavelength? V equals F lambda. No, speed is not frequency divided. That is, it should be speed is frequency multiplied by wavelength. So you have the speed 340. You have 6,800. The frequency and the wavelength is unknown. So it will be 340 divided by 6,800. What is the wavelength in meters? 0.05. So 0.05 meter. State the typical value of a speed of a sound in liquid. 1,500, 1,600, that's fine. Any range is from 900 to 2,000 is acceptable. A ray of a light in air incident on a glass block. The light changes the direction. The light changes direction. State the name of this effect. Refraction. And why refraction happen? Because of change in what? Change in speed. So because the light is changing the speed, that's why the refraction happen. As it changes the speed because of change in medium. Change in medium. Change in medium. But sometimes what happen? Where sometime two mediums may have the same densities. So the change in medium does not always true. So as you can see here, refraction because the speed changes rather than change in medium. Change in medium, why change in medium is not a comprehensive answer because some mediums have the same. You can mention change in the wavelength, but you're not supposed to say increase or decrease in wavelength. The next one is figure 5.1 is full scale drawing of a thin converging lens, which is having a focal length of 3.5. So you have to mark 3.5 on a figure, marks two principal focuses, object is there, and we have to draw an image and determine the height and whether it's real or virtual. So first, 5 boxes equals to 1, according to this scale, 5 boxes equals to 1 centimeter. So from the center, 5 boxes, this will be 1, 2, 3, 4, 5. So this will be 1 centimeter, 3 centimeter, 4 centimeter. And same way you can mark the other side, 1 centimeter, 1, 2, 3, 4. This will be 1 centimeter. This will be 2 centimeter. This will be 3 centimeter and 4 centimeter. As I mentioned, the focal length is 3.5. So between 3 and 4, we'll have the focal length focus here, and we'll have a focus here. Then we have to draw an image from this object. So first, a parallel light ray. Look, 3 rays you can take. Parallel light rays passes through the focus. One through the optical center will pass straight. One through the optical center will pass straight, and the position or the point where two light rays will meet or intersect, that is the position of image. So it will be inverted, and as well as laterally inverted as well as inverted. So if they ask, draw another light ray which is not passing through the focus. So you can draw that light ray which is not passing through focus. So you can draw anywhere, but is not passing through focus. Then you have to measure the height of this image. Using the ruler scale, you have to work out the height of this image. And then explain whether it's a real or a virtual. So it's a real image because formed by intersection of the lines. Figure 6.1 shows a wavefront approaching a gap in the barrier. On a figure, draw 3 wavefronts on the right. Which gap is this? Narrow or a wide? This is a wavelength, and here is the gap size. So wavelength and gap size looks identical. So when we have wavelength and gap size are approximately equal, maximum diffraction. So we'll draw maximum diffraction will show by drawing the curve wavefronts. If they ask what is virtual image, means the image cannot be formed on the screen. You can say the image which cannot be taken or seen on the screen, or not formed by intersection of the two light rays after refraction. You can write that as well. The gap is adjusted and it has increased 5 times. So that will reduce the diffraction. So minimize the diffraction. This is for minimum diffraction. Describe with a label diagram an experiment using water waves to show a reflection of a wavefront that occur in a spread barrier. So first thing, how to produce a water wave. So for that purpose, what we'll do, we'll take a ripple tank. And we fill this ripple tank with water. Then we want to produce a water wave. So how we can produce a water wave? So we can take any vibrating object, oscillating object or vibrating object, and place in this water. So this vibrating object, as it oscillate up and down, so it will create the water waves. And then we want to demonstrate the reflection. So how we demonstrate the reflection? So we place a large obstacle in the path of this water wave, and we'll observe the reflection. Like we can use a camera to capture this reflection of the water wave, or we can also use a stroboscope for that purpose. So describe the label with the label diagram. You have to label all these like ripple tank, water, oscillating object, water waves. And it's a 4 mark. So what are the points here? You can see these are the marking scheme points. So diagram to show the level, barrier, incident, and the curved wavefronts can be there. Then water surface or a tank, ripple tank, that we did. How the water waves are produced, how we produce the water waves. And a barrier is there, like metal object or any opaque object is there. And we can use a video camera, or stroboscope can also be used, or we can also just watch how reflection is happening. Is it clear, this experiment? Anyone having a doubt or a question in this? Even you can draw the in a diagram, for a diagram you can draw this as well. You can draw the incident, you can make a reflecting surface, and you can draw the reflected wavefronts as well. This is also acceptable, but it should be